Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0717 indicates an issue with the input or turbine speed sensor A circuit, specifically signaling that no signal is being received. In the Honda Civic models from 2011 to 2015, the input turbine speed sensor plays a crucial role in monitoring the transmission's input shaft speed and relaying this information back to the powertrain control module, PCM. When this sensor fails or experiences an electrical issue, the transmission may exhibit erratic behavior, affecting shifting and overall performance. The term circuit no signal refers to a failure in the communication line between the sensor and the PCM, typically rooted in electrical glitches rather than mechanical failures. This code underscores the significance of ensuring a functional electrical circuit for the sensor to operate correctly. Therefore, before diving into troubleshooting, it is vital to understand that this code cannot stem from mechanical transmission problems, focusing our approach solely on electrical diagnostics. The input turbine speed sensor, crucial for the functioning of the transmission system, measures the rotational speed of the input shaft. Located on the transmission assembly, this sensor transmits speed signals to the powertrain control module, PCM, which utilizes this information to optimize gear shifts and engine performance. If the sensor malfunctions or the circuit fails, it may prevent the PCM from receiving accurate speed data, leading to suboptimal driving experiences or even entirely impaired transmission operation. The transmission relies heavily on this data to perform correctly. Without it, the system may default to a fail-safe mode. Understanding its role is key to diagnosing the problem, as we focus on the electrical circuit issues, not on potential mechanical problems within the transmission unit that could affect this sensor's performance. The possible causes of the DTC P0717 revolve around electrical issues that hinder the sensor's operation. First and foremost, a faulty input turbine speed sensor itself may fail to provide the necessary signal, causing the PCM to indicate no signal. Additionally, an open circuit in either the VCC2 or NT wire could prevent electrical signals from reaching the PCM, halting communication. Lastly, shorted wiring to ground in the NT line can create a continuous circuit interruption, throwing error codes and leading to erroneous system behavior. Each of these underlying issues points towards the need for a thorough electrical diagnosis rather than mechanical examinations. The investigation must focus on the wiring and the connectivity of the sensor to ensure that the electrical complexity of the system is functioning correctly. When DTC P0717 is present, several symptoms may manifest, indicating a failure of the input turbine speed sensor or its associated circuitry. Erratic transmission shifts are often the most noticeable, with gear changes happening unpredictably or abruptly. The check engine light will likely illuminate on the dashboard, signaling to the driver that there's an issue that needs attention. In some cases, a noticeable power loss may occur, as the PCM struggles to determine the correct shifting patterns due to lack of accurate input speed data. This could lead to reduced vehicle performance and compromised drivability, causing concern for the driver. It's critical to address these symptoms promptly to avoid further complications and potential costs associated with transmission issues. The first step in troubleshooting DTC P0717 involves confirming the presence of the code itself. Begin by turning the ignition switch to the on position, also referred to as on mode, or press the engine start-stop button accordingly. Following this, use the Honda Diagnostic System, HDS, to clear any existing DTCs for a fresh readout. Next, safely raise the vehicle on a lift, ensuring all four wheels can rotate freely. Start the engine and disable the Vehicle Stability Assist (VSA) feature by pressing the VSA off button. Then, conduct a test drive, accelerating to speeds exceeding 19 miles per hour, 30 kilometers per hour, for a minimum of 30 seconds. After the test drive, again, check for the presence of pending or confirmed DTCs using the HDS. If DTC P0717 is still indicated, confirm that the failure can be consistently replicated, thereby validating it as a genuine issue to address further. In the second troubleshooting step, the focus shifts to identifying the exact area of failure within the system. First, turn the ignition switch to the off position, or correspondingly, press the engine start-stop button to ensure the engine is not running. Next, disconnect the 3-pin connector of the torque converter turbine speed sensor, as this will isolate the sensor from the circuit for accurate testing. Once disconnected, turn the ignition back to the on position. Using a multimeter, measure the voltage between the designated test points, one wire at the torque converter turbine speed sensor connector and the other to a solid body ground. Ideally, the voltage should read around 5 volts. If this voltage is present, it indicates that the wiring and the PCM connection are functional, guiding you toward the next troubleshooting step. If it isn't, further investigation into the wiring continuity is necessary. In this step, the attention narrows to checking the voltage across the VCC2 line to determine its condition. Using the same disconnect setup from the previous step, measure the voltage between the test points specified for the VCC2 circuit. This involves testing the voltage at the torque converter turbine speed sensor connector with a reference to body ground. If the voltage reads around 5 volts, this means the VCC2 wire is functional, and you should proceed to the next step in the troubleshooting process. However, if the voltage is absent or significantly lower, it indicates that there is an open circuit in the VCC2 wire that requires repair. Such issues could stem from physical damage or corrosion in the wiring, so examining the harness thoroughly may reveal faults needing rectification. During this troubleshooting step, the focus shifts to evaluating the torque converter turbine speed sensor itself for functionality. Keep the sensor disconnected and measure the voltage between the appropriate test points, specifically looking for a reading from the SG2 wire. As in previous steps, the ignition should be in the on position during this test. If the voltage measures close to 5 volts, this indicates the sensor is defective and should be replaced with a new unit to restore proper function. Conversely, if the voltage is absent or significantly off, this might point to an open in the SG2 wire, extending back to the PCM. In either scenario, identifying whether the sensor or the circuitry is at fault is crucial to addressing the underlying problem, represented by DTC P0717, effectively. At this stage, the investigation delves deeper into the integrity of the wiring associated with the circuit. Begin by turning the ignition to the off position to ensure safety during checks. Use the HDS to jump the SCS line, which helps in analyzing the sensor fault code specifics. Once that is set up, disconnect the PCM connector B, which manages various communication signals, including those from the turbine sensor. With everything safely disconnected, use a multimeter to check for continuity between the test points for the NT wire. If there is continuity detected, this suggests a short to ground in the NT wire may exist, necessitating repair. Should there be no continuity, the wiring is functioning as expected, guiding you to continue troubleshooting with the next steps. The final troubleshooting step involves another continuity check, focusing specifically on the NT line. Ensure that the ignition is still in the off mode for safety, and verify the NTC connector is disconnected. It is essential to measure continuity between the torque converter turbine speed sensor and the specific pin on the PCM connector. If the continuity is confirmed, This suggests that the NT wire is intact and functioning correctly within the circuit, thus necessitating another course of action, such as updating the PCM software or substituting it with a known good unit to see if the issue resolves. Conversely, if continuity is absent, it is clear that a break exists in the NT wiring that must be addressed to restore signal functionality. Diagnosing the wire condition accurately can prevent unnecessary parts replacement and ensure a targeted repair. Upon completing all necessary repairs and checks for the DTC P0717, it's vital to verify the repair's effectiveness thoroughly. Begin by using the Honda Diagnostics System, HDS, to clear any diagnostic trouble codes from the vehicle's memory. Following this, retest the vehicle under normal driving conditions to observe if it operates without issues. Make sure to monitor the vehicle's performance, looking specifically for any transmission irregularities or the illumination of the check engine light. Should the vehicle exhibit normal functionality without recurrence of DTC P0717, it's a strong indication that the issue has been resolved. This verification step is essential to ensure that the repairs made were not only effective, but also lasting, providing peace of mind for the driver. To avoid experiencing DTC P0717 or similar codes in the future, adopting a proactive, preventive maintenance strategy is key. Regularly inspecting the transmission wiring and connectors will help identify wear, corrosion, or other signs of damage early, allowing for timely repairs. Using high-quality replacement parts ensures the longevity and reliability of repairs, minimizing the chances of future electrical issues. Additionally, keeping the powertrain control module (PCM) software up to date is crucial, as manufacturers often release updates to improve performance and correct potential bugs. This overall maintenance approach not only enhances vehicle reliability, but also contributes to its efficiency and operational longevity, providing a safer and more enjoyable driving experience. In conclusion, addressing DTC P0717 in the Honda Civic 2011 to 2015 models requires a focused approach on the vehicle's electrical circuits rather than mechanical components. Understanding that electrical issues such as faulty wiring, short circuits, or defective sensors are at the heart of this code helps streamline the troubleshooting process effectively. Common causes, such as the input turbine speed sensor malfunctioning or wiring faults, can lead to unsatisfactory vehicle performance. By following a systematic diagnostic protocol and employing thorough checks, mechanics can ensure that repairs are not only successful, but also mitigate the recurrence of similar issues. Thus, adhering to this guide can significantly enhance the reliability and functionality of the transmission system in Honda Civics affected by this specific code. Please like and subscribe to the channel. See you next time.